Hello everyone. So in this lecture video we are going to see about the value engineering concept in product design and development. So value engineering in the context of theory of inventive problem solving are both methodologies that focus on improving products and systems, but they approach the improvement process from different stages. We focus on cost reduction and improving functionality by optimizing the value of a product, while risk focuses on resolving contradictions and fostering creative, inventive solutions. Together, these two methodologies can be highly effective when applied to innovation and problem solving in engineering and product design. What is value engineering? Value engineering is a systematic method used to improve the value of your product or service by improving the functionality while reducing the cost and ensuring that the product performs its intended function at the lowest possible cost without compromising the quality. So main objective of the value engineering are, first one is the cost reduction. So lowering the cost of production without affecting the product's quality or performance. Functionality improvement, identifying and enhancing functions that add values to the product. Optimization, achieving the best possible value in the product or process. So the processes involved in value engineering are information phase. So understanding the function and structure of the product. Second one is the function analysis phase, identifying and analyzing the primary and secondary functions of a product. Creative phase, brainstorming and generating alternative solutions or ways to achieve the same function at a lower cost. Evaluation phase, evaluating the generated alternatives in terms of feasibility, cost and performance. Development phase, developing the best alternatives into more concrete solutions. Presentation phase, presenting the findings to stakeholders and making decisions. So the aim is to improve the overall value of your product or system by focusing on functionality and cost efficiency. TRIS and value engineering, how they relate. While value engineering is primarily focused on cost reduction and function optimization, TRIS is a method for inventive problem solving that helps identify new solutions by resolving technical contradictions. So both methods aim to improve the value of your product or system, but they do so in complementary ways. Contradiction resolution in VE. So TRIS's core principle is contradiction resolution. When improving one feature leads to a trade-off or worsening another. In VE, such contradictions often appear as trade-offs between cost and functionality. Example in VE. So a product feature might require high quality materials, increasing cost, but reducing those materials may degrade performance. By using TRIS, the contradiction can be addressed through inventive solutions such as segmentation. So segmentation is nothing but dividing parts of the system to reduce material usage without compromising functionality. Local quality. So using materials in a more localized and optimized manner. So in this way, TRIS helps identifying creative solutions to resolve contradictions that would otherwise be considered trade-offs in the VE process. Innovation and cost reduction. So TRIS encourages a more innovative approach to problem solving, often leading to breakthroughs that might not be obvious in a typical VE process. By focusing on ideal solutions and removing unnecessary complexity, TRIS can lead to innovations that simplify systems and significantly reduce cost, improving the value. Function-oriented approach in VE and TRIS. So VE identifies core functions and looks for the way to reduce the cost. TRIS, through tools like the function-oriented search and ideal final search, identifies ways to perform functions without waste leading to both functional. Function-oriented approach in VE and TRIS. Next one is the key integration of VE and TRIS. So combining TRIS with value engineering can lead to more effective and creative solutions to engineering and product design challenges. Some examples are Principle 14. So it could suggest designing parts in spherical or rounded forms which might reduce material usage and manufacturing costs while improving the functionality. Resolving the trade-offs. In many cases, cost reduction in VE comes at the expense of functionality. So TRIS contradiction matrix can help break these trade-offs by suggesting alternative ways to improve both cost and performance simultaneously. So achieving the ideal final list. So ideal final list concept can align perfectly with VE's goal of achieving the best value. Practicing example of combining VE and TRIS. So redesigning a mechanical system is an example. And by using TRIS inventive principles like principle 15 or principle 4, we could propose an innovative solution, dynamically adjusting pump speed or using a different material that reduces the friction and energy consumption. Thank you.